Welcome back to West Virginia, because life is a circus, and so we're going to just be in a circus here. So are you ready for Joke of the Day? Because it is the best part of the day, and I love Joke of the Day. Are you ready? Let's do it. Why did the bacon laugh? Because the egg cracked the yolk. Well, enough joking around. Let's take a look at today's lesson. And we are going to look at equations that are quadratic in form. Quadratic in form means that it is not an honest-to-goodness quadratic, but it can take it has the impression of a quadratic. It can take the form of an honest-to-goodness quadratic. Take a look at the example that we have right here. I have a 4x to the 4th power, 13x squared minus 9. Now, if I would slide everything over to one side, and I'm going to keep my highest power positive, so I'm going to subtract my 13x squared on this side, and I'm going to add that 9 to get it equal to 0. This has the feeling of a quadratic, because an honest-to-goodness quadratic would look like this. It would look like a 4x squared minus 13, well, let's not do x squared, a 4, let's call it u squared minus u plus 9. That's what a real quadratic would look like. Squared here, second term, first power term right here, and a constant there in the back. What makes it quadratic is having that second power. I can take this and I can turn it into quadratic by making a substitution. In other words, what if I call this x squared a u? So I'm going to let x squared be a u. And what if I let this x to the 4th be a u squared? In other words, what I've done here is I've taken my u and I've squared it, squared this one, and so I've taken this and I've squared it, and x squared to the second power. When you raise a power to a power, you multiply those exponents. So basically, I've taken this first equation right here, and I've squared both sides, and that gives me x to the 4th equals u squared. And I'm taking this and I'm substituting it into the blue equation. So I'm saying, let's pull this x to the 4th out, and let's put a u squared in its place right there. Let's pull this x squared out, and let's put a u in its place right here. And that gives me an honest-to-goodness quadratic. And when I have an honest-to-goodness quadratic, I got 4 methods to solve it. I can either factor it, I can take the square root of both sides, which I can't do here because I've got that first power term. I can do the completing the square, or I can do the quadratic formula. Now, I've said many, many times, and I will continue to say it, that if this will factor, that is the easiest way to go. And it will, in fact, factor. Now, I'm looking and I'm saying there's nothing common to each one of these that I can divide out. So, I'm not going to do that common monomial factoring. I'm going to go ahead and head for that double parentheses. And remember, this back sign tells me whether the same or opposites. It's a plus, so they're the same. This is a minus, so they're both minuses. I'm going to split my 4u squared up into the front 2 slots and split my 9 up into the back 2 slots. And I have said, if it will split evenly, like a 2u and a 2u, and a 3 and a 3, 9 times out of 10, that's how it's going to go. But notice that when you check your outsides and insides on this one, out here I get a negative 6u, in here I get another negative 6u, and negative 6u minus 6u does not give me a negative 13u. So this is not the way to factor it. So instead, let's try perhaps maybe a 4u and a 1u, keeping with the 3 and the 3. So I get a negative 12 out here, and a negative 3 in here. So negative 12u and negative 3u, that gives me a negative 15u, so that's not the right way to factor it. Now notice that if I switch up the 4 and the 1, that doesn't help. So instead of 3 and 3, I need to do a 9 and a 1. So let's put a 9 here and a 1 here. Now on the outside, I get a negative 4u, and on the inside, I get a negative 9u. Those do, in fact, give me the negative 13u. So this is the correct way to factor it. And remember, that zero product principle says if I've got 2 things that are multiplied to get a 0, one of the 2 has got to be the 0. So either the 4u minus 9 is the 0, or the u minus 1 is the 0. Now this one's the easy one. If u minus 1 is 0, then the u is a 1. Here, if 4u minus 9 is a 0, then that means that 4u is 9, and when I divide by 4, I will get u equals 9/4. The only problem here is that that gives me u. But recall, I started with an x. I didn't start with a u. So that substitution that I made here that said, I'm going to make my x squared a u, I'm going to bring that substitution back in so that I can solve it for x. So in other words, this u, I am now going to turn into an x squared. So I'm going to say x squared equals 1. Now, from there, I'm going to take the square root of both sides to figure out what x is. Square root here, square root here. And notice the square root was not already on the page. I took the square root. So that indicates plus minus. And then same thing here. I'm going to put that substitution in there. And now I'm going to say that u is going to go back to the x squared. So that means that I'm going to have x squared equal to 9/4. And yet again, in order to solve that, I'm simply going to take the square root of both sides. And once again, square root was not already on the page. I put it on the page, so that indicates plus minus 3/2. Now, I just need to be very careful about those extraneous solutions, so I do need to check and make sure that this will work. When I go to check it and I put my plus minus 1 in here, plus minus 1, or 1 to the 4th power is 1. Negative 1 to the 4th power is going to be 1. So this is going to be 4 times 1, which is just a 4. And now when I put my 1 in here, 1 squared is 1. Negative 1 squared is 1. This is 13 times 1, which is 13. And so I'm going to have 13 minus 9. 13 minus 9 is 4, so the two sides are definitely equal. So it definitely works. Now let's check, and let's go ahead and circle it because it definitely works. Now let's check our positive minus 3/2. And if we go to check our x equals plus or minus 3/2, notice that when we put the plus minus 3/2 in here, put it in here, we're going to raise it to the 4th power here. Now 3 to the 4th power is 81, 2 to the 4th power is 16, a positive to the 4th power is positive, a negative to the 4th power is also positive. So we have 4 times 81 over 16. These 4's will cancel. 4 goes into 4 once, 4 goes into 16 4 times, so you get an 81 over 4. When you check it and you put your positive minus 3/2 in here and square it, 3 squared is 9, 2 squared is 4, positive squared is positive, negative squared is positive, and so when I multiply here, nothing's going to cancel. 13 times 9 is 117 over 4, but remember I need to subtract a 9 here, and 9 is 36 over 4, and a 117 minus 36, sure enough, is an 81 over 4. So this one works as well. Both of them are solutions. And recall me mentioning that the highest power tells you at most how many solutions you should get. Sure enough, we got 2 here and 2 here. And that gives us 4 solutions. Now, let's take a look at another example just to make sure we're very good at this. And notice that in this second example, looking a little bit weird because we have a square root in there. Here is where a substitution becomes very helpful because this is quadratic in form. It doesn't feel like it's in quadratic in form, but it is. Because what if I called this square root of x a u? So I would have negative 7u. But notice that if I square the x squared, I get an x. And if I square the u squared, I get a u squared. So that means I can substitute right here for this x, and I can put a u squared in there. And see, that's what makes this quadratic in form, because I can turn it into an honest-to-goodness quadratic. Honest-to-goodness quadratic will have first power, and you double that to get this one. If I double this, I will get an x to the first, or double the exponent, I will get an x to the first. So now that I've turned it into an honest-to-goodness quadratic, then that means I'm going to solve it by any of those 4 quadratic methods. I'm either going to factor it, I'm going to complete the square, I'm not going to take the square root of both sides because this is messing that up, or I can use that quadratic formula. Let's see if maybe it will factor. Now, there's nothing common that I can divide out of every single term, so I'm going to go ahead and go for that double parentheses. This tells me I've got opposite signs, one's a plus, one's a minus. I'm going to split my 2u squared up as a 2u and a u. I want two, and I can't say I want two numbers that will multiply for 30 and subtract for 7 because this 2 over here is messing that up. But I do have several options with the 30. I can try a 30 and a 1, I can try a 15 and a 2, I can try a 6 and a 5. I'll start with the 6 and the 5 and hope for the best. Now, on the outside I get a negative 10u. On the inside I get a positive 6u. That gives me a negative 4u. So it's not even the right number. Changing signs is not going to help. So I'm going to try to switch the numbers up before I just toss them aside and try a different set of numbers. Now on the outside I'm going to get a negative 12u. On the inside I'm going to get a positive 5u. And that'll give me a negative 7u. Oh my goodness. That was pretty quick. I got it. So these are the correct factors. So here's my zero product principle that says one of these two has got to be the 0. So either the 2u plus 5 is the 0, or the u minus 6 is the 0. Now, if this is the 0, u is going to be 6. If this is the 0, I'm first going to subtract a 5, and then I'm going to divide by a 2. And I'm feeling pretty good other than, remember, I did not start with a u, I started with an x. So I need to take the substitution that I made and I need to bring it back into the equation so that I can figure out what x actually is. So I made a substitution up here that said, let's let u be a square root of x. Actually, I said, let's let a square root of x be a u. But now I'm going to take the u and I'm going to turn it into my square root of x. And at this point, I'm ready to get the x completely by itself. Currently, it's being square rooted. The opposite of square rooting is squaring. So I'm going to take my square root of x and I'm going to square it. And I'm going to square the other side as well. Squaring and square rooting cancel each other out. I get just an x. And 6 squared is 36. I'm going to do the same thing over here. I'm going to square this side. Squaring and square rooting cancel each other out. And I'm going to square this side. Now, recall, negative times negative is positive. 5 squared is 25. 2 squared is 4. And I just need to check and make sure that these actually do work. So when I check my 25 over 4 and plug that in for x here and here, I have 2 times 25 over 4 minus 7 times square root of 25 over 4 minus 30. I better come up with a 0 when I do all that. Now here I'm going to cancel the diagonals. 2 goes into 2 once, 2 goes into 4 twice. I get a 25 over 2. Here, square root of 25 over 4 is going to be 5 halves. So I'll have a minus 7 times 5 halves, which incidentally, 7 times 5 halves is going to be a 35 over 2. So I have a 25 over 2 minus a 35 over 2, which is a negative 10 over 2, and negative 10 over 2 is a negative 5. So I have a negative 5 minus 30 equal to 0, which is a negative 35 equal to 0, and that's absolutely not true. So that means that my 25 over 4 is what we call an extraneous solution. In other words, it should work, but it doesn't. An extraneous root. And now I'm going to check my 36. So I'm going to plug my 36 in here and here. So 2 times 36 minus 7 times square root of 36 minus 30, and I better come up with a 0. So 2 times 36 is 72. Square root of 36 is 6. 7 times 6 is 42. And 72 minus 42 is 30. 30 minus 30 is 0. So yes, this does in fact work, and that's my solution. So hopefully you're seeing that with your quadratics, or I'm sorry, equations that are quadratic in form, best thing that you can do is you can use a substitution to make it an actual honest-to-goodness quadratic. Once you do that, you can solve it with any of those 4 methods for solving your quadratics, and then you can use that substitution to find the value of the original variable. Now, some of you are looking at this one and you're saying, now wait a minute, what's written in blue, I would have handled that completely differently. I never would have made a substitution. And you're right. You can solve this one without making a substitution. Now, the other one that had the square root in it, that is very challenging to do without using a substitution. The substitution is the best way to go with that equation. But let me go with those of you who are saying, I never ever would have made a substitution into that blue equation. Let me go ahead and work it out doing the way that you're thinking of doing. Because many of us will take a look at this blue equation, 4x to the fourth minus 13x squared plus 9, once we've set it equal to 0, many of us would say, well, I can factor that. And you're exactly right, you can factor that. It will factor as a 4x squared minus, where did it go? 4x squared minus 9 and an x squared minus 1. Because on the outside I'll get a negative 4x squared. And on the inside I'll get a negative 9x squared. And that does give me my negative 13x squared. Now from here there's a couple of ways to go. One way is to say, I'm going to go ahead and say that this 4x squared minus 9 is 0, and the x squared minus 1 is 0. Here, this will give me x squared equals 1, and I'll take the square root of both sides, giving me x equals plus minus 1, which is exactly what I had right here. Here, if I add 9 to both sides, and then divide by 4, I'll get 9/4, and when I take the square root of both sides, the square root of 9/4 will give me plus minus 3 over 2, giving me the very same answers. And this is a perfectly fine way to do this one. Like I said, the other one with the square root already in the beginning, that's one that works much better by using that substitution. Some of you, though, right here would have said, no, wait a minute, didn't you say to look and see if I can factor this further and this further? And you're right, I have said that many times, and you're right, they will factor further. So if that's the case, I can take this one and I can say this becomes a 2x plus 3 times a 2x minus 3. This becomes an x plus 1 times an x minus 1. And here I've got a whole bunch of parentheses being multiplied together to get a 0. But my zero product principle still says multiply together to get 0. One of them has got to be the 0. So either this is the 0, or this is the 0, or this is the 0, or this is the 0. Now if this is the 0, x is 1. If this is the 0, x is negative 1. But look, that's what we had here, plus minus 1. If this is the 0, I'm going to add 3 and divide by 2. If this is the 0, I'm going to subtract 3 and divide by 2. Here again, getting plus minus 3/2. So you're right. You don't always have to take something that's quadratic in form and use that substitution. Sometimes if it'll factor beautifully, you just keep factoring. Just keep factoring, just keep factoring, 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 until you can't factor anymore. And that's a perfectly good way to do this. So I hope that helps with equations that are quadratic in form. You guys have a fantastic day.